So hello friends, welcome back to our channel. So today we would be deriving the relationship between Kc and Kp by using our formula Kp, okay? Our Kp's formula is the pressure of our products divided by pressure of our reactants, okay? So the reaction is given this way. Ca plus B reacts to form C plus D. C plus D are our products, C, pressure of C and pressure of D, and divided by A plus B are our reactants, so pressure of A into pressure of B, and they are raised to these respective coefficients, stoichiometric coefficients. Stoichiometric coefficients, you all might know that the reaction may be like this. See, they may have some coefficients of their own, right? Like 2H2O, then 2 is the coefficient of H2O. Similarly, see, we'll write a reaction like this. So they are, see, these are the stoichiometric coefficients of the respective reactants and products. Okay, so to these coefficients, the pressure of reactants and products are raised. Okay, so this is Kp's formula. So we'll be using this formula to derive relationships. See. So as you all know, this is a formula. So the next step we'll be using is that we'll be using our equation PV is equal to nRT. As you all know, PV is equal to nRT. So we'll be writing like this. P is equal to nRT divided by V. So it's multiplication. So it's multiplication. So we can write like this. P is equal to N by V into RT. So as you all know, N by V is also known as concentration. You all know what's the formula for concentration? Number of moles per volume. It's concentration, right? So we got concentration. So what we will write? P is equal to CRT. And we will keep this as equation 1. So we will be using this equation, okay? Now see, let's go back to our equation. Kp is equal to pressure of C raised to C into pressure of D raised to D, means they are coefficients, and divided by pressure of A into pressure of B raised to D coefficients. So in the next step, we'll be writing that Kp is equal to, I told pressure is CRT. So pressure of C, this pressure of C, I'll be writing as concentration, this C of C R T raised to their coefficient C, because this coefficient, because it was raised to our pressure, right? So we should use this coefficient as a whole square, not square but as a whole. We should raise it to this power, this coefficient. And similarly we can write it like this. The other products we can write it this way by using our formula, and we should divide it by this. Okay, don't forget to raise it to the coefficients, okay, because it is given as raised. See, now of this step finished, okay, completed. So we'll be using our doing our next step. In our next step we'll be distributing them, okay? Means, as you all know, if AB is raised to 2, then if they're squared by whole bracket, then we'll be using, when we break them or distribute them, then we'll be writing A square, B square, right? You all remember this, right? So we'll be using the same thing. We'll write that concentration of C raised to C and RT raised to C into concentration of D raised to C, RT raised to, sorry, it was D, and RT raised to D divided by concentration of A raised to A and RT raised to A into concentration of B raised to B and RT raised to B. Okay, understood this step? Okay, so our next step is really easy. Now, our next step, we will be writing this in a different way. As you all know, instead of writing concentration of C and concentration of D, we can write concentration in a different formula. See, this is also known as concentration of C. So we can write it this way. RT raised to C into, similarly, this is also known as concentration of D. You all know this notation, right? It's been taught in equilibrium chapter, class 11. So we can write it like this, and this like this, divided by concentration of A raised to A, RT raised to A into, like this, B raised to B, RT raised to B. Okay, so this over this equation. In our next step, we can take the like terms to the same side, means concentration we will be shifting them to the left side. Okay, C, concentration of C raised to this, and these things we will write to left side, and this RTs. As you all know, R is constant, 0.083 its values, and this T, the temperature for a given reaction, will be constant. So they are like terms. So we're going to take them to this side. Okay, we're going to take them to this side, divided by, similar way we will have to do here. See, this is really easy. I know you will be able to do this. See, so in our next step, it's really important to note the step. See, the concentrations are same. Okay, we can note it down directly. See, like this. But in here, RT, they both are same. Okay, I told in a reaction they will be same. R is always constant and T would be same in a reaction. So we're talking about a reaction, so we can write RT common, and we'll have to add your powers, C plus D. This is a formula given. Okay, this is a basic formula. A raised to M into A raised to N gives A raised to M plus N. Okay, we are using this formula here, and similarly we will have to do the same thing downwards, means in the denominator. We are gonna bring them same, we already brought them, and now we're gonna RT A plus D raised to A plus B. Okay, so I hope you all understood this much portion. So that's our last step, right? So now you see here this RT same and RT same here, so we can take this RT upwards. So what will happen? See, this is gonna remain same as I told, and this is also gonna remain the same. And here we are gonna take this both RT to the same, so it's gonna be divided by RT. So we are going to minus its power. The power here, we are going to minus it. See, I can give you an example, okay? Then you will understand this process really fast. Whenever we take, like, for example, A raised to M divided by A raised to N, it's gonna give us A raised to M minus N. So we're gonna use this formula here, okay? See, RTC plus D divided by RTA plus B, gonna take RT as common, and we're gonna minus their powers. Okay, we minus them. So what's gonna be our next step? We will have to write the denominator also. It's gonna be concentration of A raised to its stoichiometric coefficient, and concentration of B raised to its stoichiometric coefficient. Okay, now we got this much portion. So first we will consider this one, this C plus D minus A plus B. So what was the reaction? Our reaction was this, right? So in here, as we all know, the stoichiometric coefficients give the number of moles of this reactants or the product. Okay, so in here, C plus D means the stoichiometric coefficient of this our products. So when we are minimizing number of moles, means we are minimizing number of moles of reactants, number of moles from products, number of moles, and what will we get? We get the change in moles, because the reactants are getting converted to these products, right? So we are gonna get change in mole, means change in moles we are gonna get, which means nothing but delta N. So this is equal to delta N, because we are getting a difference in the moles, right? After the reaction, what's gonna get? We're gonna get some specific number of moles here in the product side and some specific number of moles in here in the reactant side. So when we are minusing the number of moles, it gives us delta N, which is nothing but change in mole. See, so our next step is we are gonna write this as same. Okay, this doesn't differ from our some couple of steps forward. From there we are gonna write this same, but here we are gonna write this delta N. Okay, and don't forget this delta N means change in number of moles in gaseous state. Means we are only gonna minimize the number of moles from the gaseous place. Means if they are in the gaseous state, only then we'll be using this. In this state, I'm considering everyone are in the gaseous state. Okay, only consider gaseous state means gas. See, we're talking about gas. So our next step would be this. Okay, so I know that you all might have been, you all are familiar with Kc, right? We all know that Kc. Let's simply recall it. What is Kc? Kc is nothing but the the concentration of the products raised to the respective coefficients divided by the concentration of reactants raised to their respective coefficients. See, now here I'm getting this similar to this portion. See, on this much portion, you see, these both are same, right? So when we're getting this both same, then what we can write? In place of this much, we can write what? Kc, and into RT raised to delta N. And this is our formula of the relationship. See, now what's the relationship between Kc and Kp? Kp is nothing but Kc into RT raised to delta N. So delta N means change in number of moles in gas. For example, I'm gonna write one question here. Means reaction CO2 plus C gives 2CO. In here, if we are being asked to find delta N, then what are we gonna do? First, there's the coefficient here, and here coefficient is nothing but 1. Okay, here coefficient is 1. But see, in this question, our C is in the state solid. We all know that graphite, it reacts with graphite. See, so it's state is solid, while the rest both are in the gaseous state. Okay, so when this thing happens, then we are going to only consider the gaseous thing. Okay, here what's the number of moles in CO? CO is a gas, so we're considering it, it's 2. Then we'll be writing 2 minus what's here? Gaseous state. Only CO2 is present in gaseous state, so we're only considering 1. So 2 minus 1, which is nothing but 1. So delta N is going to be 1, and then our equation is going to be Kp is equal to Kc into RT, because delta N is 1. Okay, so I hope that you all got my example and understood the concept of the relationship between Kp and Kc. So we derive what is the relationship. The relationship was found out to be Kp is equal to Kc into RT raised to delta N. Okay, so thank you and have a wonderful day ahead.